Good afternoon, Rich Nass, Executive Vice President with Open Systems Media and leader of the Embedded Computing Design franchise, here for another video where we are talking about COM-HPC on behalf of the PICMG organization. As you probably know by now, there's a series of 8 videos, and each one looks at a different aspect of COM-HPC. In this particular video, we're going to talk about the considerations for carrier design. And to do that, I've asked Chris Engels to join us. He's with Avnet. Hello, Chris. How are you?
Hi. Thank you. Thank you very much, Rich. I'm good.
Good. Before we start your presentation, the one thing I just want to get out there is when we talk about carrier board design or carrier boards in general, what is your definition of a carrier board? So everybody's on the same page from the beginning.
Yeah, I mean, in my industry, this is really much related to computer on modules. So the philosophy of computer on modules is there's some standard item with following a standard, and it's a replaceable component which you could upgrade with more performance or newer technology or different supplier, and you have an underlying carrier card which actually enables the application for the specific needs with specific I/O. It can be very much custom to a very specific architecture, and it makes, by using this computer on module philosophy, it just makes it very, very flexible and widely usable over a long period of time. Yeah, thank you very much, Rich. Yeah, I talk about COM-HPC carrier design today. Pretty happy to be here with you. So this is a series of presentation sponsored by various companies who also were participating in the COM-HPC specification development. I said I talk about the COM-HPC carrier design. I will touch base about some architectural considerations which are important to make. We look at high-speed signal integrity, at power and cooling, which is also some important aspects. And then I talk a little bit about design aids and how the ecosystem, the module suppliers can help you and assist you in the development of carrier designs. We talk about architectural considerations. This is really much about the application itself. So you might have a specific application in mind, a specific equipment you want to develop for your industries and your markets. So we have a set of application requirements which define the functionality and the capabilities of the equipment. If you break that down further on, then you have specific needs for system throughput, performance, bandwidth. You want to connect specific interfaces like sensors, cameras, or human-machine interfaces, displays, and so on. And there might be external networks the equipment needs to be integrated into. Further on, mechanical requirements, housing, packaging, rack installation, cabling inside the system, outside the system, the power distribution from external. This all play into role when you talk about the specification of your application equipment. And finally, there are environmental requirements like thermal, shock and vibration, safety requirements, and so on. If you break that down into individual components inside your design, then you also touch the COM-HPC module and the COM-HPC carrier. And those steering requirements have an impact on the module requirements as well as the carrier requirements. When designing for COM-HPC, you have to do some fundamental design decisions. First of all, there are 2 different types of interfaces. So we have to make a decision if you want to design for a COM-HPC server interface or for a COM-HPC client interface. I come to that point in my next slide a little more detailed. But basically, you're looking for specific interfaces, the type of interfaces, the number of interfaces. You want to connect the range of scalability you want to achieve and the performance class. So basically, you also have to look at the system on chip or processor technology, which resides on the COM-HPC module, but that certainly is an important step also to select the right module for your application. And finally, there's also the choice of different sizes of COM-HPC modules. And the specification for the two different interfaces also requires that you have different gaps between the two COM-HPC connectors, which are defined in the standard. So you have to make a very fundamental design decision, trying to achieve or to accomplish both COM-HPC client and server interface on the same carrier design. I would say is not impossible, but it can be quite challenging because you have to deal with high-speed signaling. And if you have additional connectors or connector footprints, at least in your design, so that puts some extra stress on the signals. As said, there are two interface or choices for two interfaces defined in the COM-HPC specification. There's the COM-HPC client and there's the COM-HPC server interface. The client interface gives you up to 4 graphics interfaces, which can come out of system on chip located on the module. So you can direct use of those. Well, these designs can be quite compact. Still, it provides you a sufficient set of PCI Express and Ethernet connectivity and sufficient real estate for the performance class, which is addressed by system on chips for this kind of applications. But if you have applications where you have to connect have to connect many PCI Express devices and many Ethernet devices, then the COM-HPC server interface is the right choice to go with. Here you don't have the graphics interfaces, but it gives you more footprint in terms of other I/O. So this is a very fundamental decision, and I think you have to make it in a very early stage of your project and don't change it again afterwards. When you're going into the design, you deal with high-speed interfacing or high-speed signaling, basically. So PCI Express is a very important interface in COM-HPC, and it's really maximizing the bandwidth of I/O to the module or from the module to the carrier. So with PCI Express Gen 3, 4, and 5, we have a lot of choice in terms of bandwidth. And if you consider Gen 4 and Gen 5, then you reach signal levels, bandwidth levels of 16 and 32 gigabit per second. So this is really high frequency stuff. It provides you a lot of connectivity in terms of external network controllers, FPGAs, additional PCI Express cards or storage cards you would like to connect. But as said, in terms of signal integrity, you have to respect what the specification actually provides here in guidelines in terms of maximum trace length and loss budgets. The other great area of connectivity for COM-HPC is definitely Ethernet. And also here, the specification provides a lot of, or many choices, which you can implement on the carrier. There's the N-base-T interface, which is 1G up to 10G. Base-T technology. For both the client and the server, 1 interface is mandatory. And for the client, you can have up to a maximum of 2. And then there's the N-base, so-called N-base KR and KX, which is a term defined in the specification. There's up to 2 interfaces possible on the client interface and up to 8 and a minimum of 2 on the server interface. What exactly is behind those interfaces really depends on the implementation of both the module and the carrier. So depending on what type of Ethernet technology you actually want to connect, for example, over an optical cable or a copper cable, really steers the selection of the components both on the carrier and on the module. And there is a relationship between the network or system on chip devices located on the module and, for example, the PHYs which are supported in that combination. So this is a very critical selection process or selection step, and you have to work. It's very, very strongly recommended that you work with the supplier of the module to identify the right component which belong onto the carrier card. And also here, there are signal integrity recommendations defined in the specification, which help you to keep in the boundaries of the maximum trace lengths and the loss budgets. And there's some simulations have been done for specific topologies. So one is module carrier to an SFP or a PHY, and the other one is a module carrier to module connection. USB is another field of high-speed tunneling. Here the speeds go up to 10 gigabit per second with the older standards, which are good for USB-A. But if you go beyond that, up to 20 gig per second, this is really the field of USB-C implementation in order to cope with the various signals here. This requires some extra logic and extra power circuitry on the carrier design in order to cope with Thunderbolt or display mode at the USB-C connector. There's also some software work involved, and it really depends also on the supported devices on the selected COM-HPC module. So also here, you need to work with your supplier of the module to find the right architecture and find the right technical solutions. Another area for high-speed signaling is definitely the graphics interfaces. So if you have chosen the COM-HPC client interface, you might have display outputs, and there the speeds can also go up to 10 gig per second. Same here. So you need to select the right components, connectors. You might also need some level shifters in order to cope with the maximum cable lengths you want to support. And there's also some dependencies between maximum achievable bandwidth and the maximum amount of independent displays connected. This really much falls back to the capabilities of the system on chip, which provides those interfaces. Yeah, while we're talking about high-speed signaling, when you have done your design and you have the PCB in your lab, I mean, you have to do some critical design validation on the high-speed signaling. This typically requires some test setup. You need to have appropriate DSO technology, which can measure and support the targeted bandwidth and the targeted interface types. This is just an example here from our labs, how we test those interfaces. I think this one here is testing DisplayPort right now. So these results really give you some information about the quality of the signals coming out. And finally, you want to achieve a specific good eye diagram, which has a repeatable quality you later on want to see also in the mass production. Yeah, my final slide on signal integrity is about PCB material selection. The COM-HPC committee has done a great job on doing a lot of signal integrity simulations and also considering different PCB material, which can be used for the high-speed signaling. There are examples for stack-ups and signal trace geometries, but most notably, there are simulations for the trace lengths, the maximum trace lengths, and the loss budgets for different high-speed signals in relation to the PCB material. And actually 4 different kind of PCB material has been selected, from standard loss material down to very low loss material. Certainly a material with low losses is advantageous, but it's more costly. So you need to find the right trade-off between the supported bandwidths you need in your application and the cost in order to implement it. A good trade-off would be if you try to design keep component in specific range to connectors, or keep the size of the carrier PCB compact enough so that you actually can take the standard loss material or a one class above of that. Different topics as the power distribution. I mean, really much is dependent on the application, what kind of power entry you would have. A telecom environment, you might have a minus 48 volt. In other environments, you probably just have a 12 volt rail, which is ideal because then you can pretty much use the 12 volt for powering the module itself. The specification defines a standard 12 volt for the server module and also for the client module. But you also have the option to define or design for battery support. And then you have 8 to 20 volt power input, but that is exclusively for the COM-HPC client module. If you design that way, then consider that someone might plug in a standard module, which only runs at 12 volt, and then you definitely need some physical protection for the module and also for the carrier itself. There's a type info coming out of the COM-HPC module, which can be used by a type detection, and then in turn that would power on the COM-HPC module by power switches, or leave it powered off if it's a mismatch between module and carrier. So this is a good protection, and it's a straightforward approach here. The cooling is a different area and is a very wide field. The specification specifies heat spreader. Heat spreaders are good if you have a reasonable amount of dissipated heat, say up to 40, 50, 60 watt range or so maximum. And the specification only specifies the top surface of the heat spreader in relation to the top surface of the PCB of the carrier. And that allows actually to replace modules from different families or different solution providers while keeping the cooling solution the same, assuming that the power dissipation are in the same range. But as said, cooling can be very different in type. Others might use heat sinks, either with a blower on it, or you have an external forced air cooling. However it's done, it needs careful planning, both for the carrier design, so that you have room or space where air can actually flow, that you have space for the metals, for mounting materials, for baffles. And it's quite important to do some thermal studies. Ideally, you do a thermal simulation and thermal testing. Go challenge your supplier of the module. They can provide you with thermal modules or with simulation tools or simulation helps. My company does that, for example. And they also can do verification of qualification if that is required. That brings me to another topic, and that's design aids. So COM-HPC is really new, and there's not much out there yet. So you need to start from scratch, because it will be your first COM-HPC design. So take all the documentation you can grab, all the design aids you can get in order to do your design. There's certainly the COM-HPC specification, which is a great source of information. So please buy the specification from the PICMG. It's worth all the money. There will also be a COM-HPC design guide, which gives you additional valuable tips. And I think there's also further documentation on the way regarding system management. And certainly you have lots of documentation from the various I/O controllers, retimers, connector manufacturers, you name them. And please challenge your module vendor, because those give you additional information. So my company, Avnet, for example, provides reference schematics and reference kits, which help to accelerate the design process. You can also give design-in support and make design reviews. You can get signal integrity or thermal data, get simulation support. You could also ask for custom design services. So this is, I think it's a great area where you can get a lot of help in order to start your first COM-HPC design. In terms of bring up and also development of a COM-HPC carrier, also starter kits or reference kits are ideal. So those typically would contain the module itself or a selection of a module, the carrier, additional mounting material, cooling solutions, memory if that's necessary, documentation, cabling, everything you need to start, put it together in the lab and do your first tests and trials with the module. You can connect your own I/O or displays. You can start software development based on that. So basically, this can help to shorten your design cycles or do, because of the concurrent engineering, start earlier already with software development. Also here, ask your ODM partner for getting the material and getting all the data you need for doing these kind of steps. Yes, so a reference kit is quite handy to have. So it typically comes with a module, with a cooling solution, which you might have to put on top. So this is good for the lab environment. So it typically has a blower, so to cope with the power dissipation, it might not be the final cooling solution. And then you also have the carrier. So you add the module to the carrier, do all the necessary cabling, and you might also add some additional modules, storage modules, PCI Express cards, USB devices, what you need for your application or for your testing to start with. Yeah, and you certainly need also some SSD or external network connection in order to bring software onto the machine. As said, it's a great start to start early testing, evaluation of external hardware like displays and so on, and do the software development. Those cards typically come with some standard motherboard form factors, which also allows to integrate the starter kits into some packaging. It's maybe not be the regular case, but in some cases, if you need to have the test equipment somewhere in an environment where you have to protect it, this might also be a solution. Yeah, and finally, here just two examples of the COM-HPC carrier and the module. So these are early boards which we have developed at Avnet based on the client interface. So these are first starters to go with if you want to go for a carrier design based on the client interface. Typically, such boards come with a sufficient amount of I/O, Ethernet, PCI Express storage, PCI Express. So it gives you a lot of room in terms of flexibility close to your application. They certainly are not a replacement for your own COM-HPC design, which might be looking completely different, but it can be a good start off, and also gives you access to the processor technology. Certainly, the ecosystem will evolve over time and will provide newer processor technologies when they come available on the markets. So if you're interested in further products in COM-HPC, the ecosystem will provide more solutions in the future based on upcoming processor technology when it becomes available. If you're interested in, please feel free to visit our website to get more information or contact us directly. We can update with future products based on COM-HPC. Thank you very much.
Well, thank you, Chris. That was very interesting. You made a comment about sufficient performance. Is there a particular number where engineers should be looking at if they want sufficient performance? What do you what do you deem sufficient performance in order to move on to COM-HPC?
Yeah, you briefly touch base here an area when actually is there a move over from COM-Express to COM-HPC. I mean, a lot of people today have COM-Express solutions, and they certainly would like to stay there with their existing solutions for as long as possible. So as long as your performance requirements can be actually addressed by the existing solutions out there based on COM-Express, I don't think that you have a big need in order to change over to COM-HPC. But if you have applications where you actually see that COM-Express comes to performance limitations because you can't, for example, can't use the maximum frequencies or maximum power dissipations of specific CPU families, or if you don't achieve the right amount of PCI Express or Ethernet connectivity, then it's time to talk about COM-HPC. And then there you may make this kind of decisions, what range of performance you actually want to address. Yeah,
Perfect.
Just say stay in the thermal design power of 45 watts and just have the additional connectivity and using PCI Express Gen 4 or Gen 5, or if you need to go with CPUs up to 80 or 100 watts range, that really depends on what your application requires.
Okay, great. Thank you, Chris. That was Chris Engels. He is with Avnet. I advise you to check out all the other videos as they look at a different aspect of COM-HPC.